Now we're going to convert from rectangular coordinates to polar coordinates. So if we're given the coordinates x and y, in this case which are -1 and 1, we want to find r and theta to represent the polar coordinates. So the best equation we can use in this case that's going to get us through the quickest is going to be x squared plus y squared equals r squared. So if we just take our x and y points, we can put those in here. So we've got -1 squared plus 1 squared equals r squared. That comes out to be 2 equals r squared. So r is going to be positive or negative square root of 2. Now comes a little more of the tricky part. We want to find theta. And if you remember back to the first part of the intro to polar coordinates, is that polar coordinates for P are not unique in the way that they can be represented multiple ways, with like a positive r and an angle theta, or a negative r and an angle theta plus pi. So first off, to find theta, we know that tangent of theta is y over x. So if we have the coordinates -1, 1, tangent of theta is going to be 1 over -1, which is -1. And so we know that tangent is negative in the second quadrant and in the fourth quadrant. And I've represented this here with these triangles. And so here, imagine that this is the origin, and we've got our point -1, 1, well, the ratio just gives us -1. And down here we can also get -1, because if we do opposite and over adjacent here, if this is the origin and that's theta there, then we're going to get -1 over 1. So we know which r value to give which angle because we know where the point actually is. So we have the -1, 1 over here. So we're going from our origin, we're going forward this way at the angle of 3 pi over 4. So we know our r value is positive for this angle. So we're going to keep that angle, and we're going to give the positive square root of 2 with the angle of 3 pi over 4. That's one way to represent this. The other way, down here, we know that the r is going backwards in a sense, so we're going to have, because the actual point will be up here, like it is right here. So since the r is going backwards, it's going to be negative. So if it's less than 0, we take our angle and add pi to it. So we take 3 pi over 4 and we add pi, which is going to give us 7 pi over 4, which we can also call negative pi over 4, as illustrated right here. So the other way we can represent this polar coordinate is with the negative square root of 2 and an angle of negative pi over 4.